Here's an example of implementing private VLANs. We are dealing with the same subnet here. The subnet is 192.168.1.0/24, and you can see that the PCs are addressed appropriately for that subnet, and this would be the default gateway, which also have an IP address in that subnet. And what is the VLAN? What is the VLAN we are dealing with here? VLAN 100. So that would be our normal setup, our normal configuration if we weren't using private VLANs. But now for the private VLAN example, we need to carve up that main VLAN. We leave the addressing the same. We leave that primary VLAN as is. Let's not change that. All we have to do now is create sub-VLANs within that VLAN. So VLANs within VLANs. And then when we associate the ports on the switch with these sub-VLANs, it's the switch that has the ability to control the flow of traffic between all the different switch ports. So let's examine the switch right now. Here is our input-output module. So just think of these as the ports on our switch. And they're color-coded right now because they are associated with a certain secondary VLAN. But before we get to secondary VLANs, let's describe the primary VLAN within the private VLAN. So the primary VLAN is that main VLAN. So VLAN 100 with the IP address associated with it. Now we carve it up, as we can see. We carve it up into these different secondary VLANs. And when we associate that port on the switch with those secondary VLANs, as you see here, it allows for that layer 2 isolation that we're trying to achieve. So as traffic flows in a particular interface that is part of a certain secondary VLAN, the switch has the ability to determine whether it can truly go to the destination that that frame or data is intended for based on the memberships of these interfaces and their secondary VLANs that they belong to. So what type of secondary VLANs exist? Well, there's community VLANs and isolated VLANs. Let's talk about the community VLAN first. The community VLAN allows us to create groups. That's the way you want to think about it. If you want to have a group of devices communicate with each other, you put them in a community VLAN because devices within the same community VLAN can talk to each other. And we see that right here. If this port is part of community VLAN A and so is this port, they can talk to each other. But if you create multiple community VLANs, and there's no limit on the number of community VLANs you can create and associate with a primary VLAN, there's no limit to that. So if you create multiple community VLANs so you can have multiple groups of devices, well, devices in different communities can't talk to each other. So there's an isolation that you have from a layer 2 standpoint, even though all the devices that are connected to this switch are all in the same subnet. They're all part of the same primary VLAN. When we go into the sub-VLANs, the secondary VLANs, what do we have? We now have that isolation. And everybody in community A can talk to each other. Everybody in community B can talk to each other, but they can't talk across communities. So there is that isolation we have, or the ability to control that flow of traffic between those switch ports. There's also that isolated VLAN. And the isolated VLAN is designed to isolate a device. That's right, isolate a device. Now you can only have one isolated VLAN associated with your primary private VLAN. And if you want to isolate a device from everybody else, then you simply place it in that isolated VLAN. So in this case, we have isolated VLAN A. That means that if there's a device connected to this port, it can't talk to anybody else that is part of isolated VLAN A. It's not possible. In addition to that, anybody in an isolated VLAN cannot talk to anybody that is part of any community VLAN. So they are truly, truly, truly isolated from everybody else. But how far does this isolation go? Well, you've probably been wondering, what is this red dot? I've seen it multiple times now, Raymond. Well, it's the promiscuous port. And the promiscuous port is the port that gives everybody connectivity to the outside world. What do I mean outside world? Everything beyond that primary VLAN. So if our primary VLAN is VLAN 100 and we have all these secondary VLANs in it, if you need to communicate to the internet or maybe with a device in a completely different subnet or VLAN elsewhere in the environment, that communication flows through the promiscuous port. So in this case, it is that promiscuous port that is going to be the uplink from our switch. And notice here it says you can implement access control list rules. So through the use of access control list rules, we can now control at a layer 3 standpoint the traffic flow out of the environment. So maybe we want to control further the community VLAN or the devices in the isolated VLANs from communicating to certain devices elsewhere in the environment. Well, then we can apply access control list rules there as well and further control the flow of traffic. So you really need to understand this terminology. What did we cover? Primary VLAN, secondary VLAN, community VLANs, isolated VLANs. Those are both those are both secondary VLANs. And we also mentioned the promiscuous port. So you need to understand these terms and you need to understand the flow of traffic between these different types of VLANs.